Hello everyone, myself Michael Ravina, Associate Professor, Department of Computer Science and Engineering. In this video, I am going to explain about priority queues and binary heap. Priority queues. In a priority queue, actually an element with high priority is served before an element with the lower priority. That means suppose if you have two elements have the same priority, means they have served according to their order in the queue. The priority queue contains two types. First one is maximum priority queue and then second one is minimum priority queue. Maximum priority queue means in the maximum priority queue, elements are inserted in the order in which they arrive. They queue and always maximum value is removed from the queue. For example, suppose in a queue, the values inserted in the queue is in the order of 8, 3, 2, 5 means removed. If it is a maximum priority queue means then we need to remove the element. First one is 8 because from these elements in the queue 8 is the maximum element, so that is removed first. This is a priority queue. This is a priority queue behind the maximum priority queue. The next one is the minimum priority queue. It is just opposite of the maximum priority queue. The minimum priority queue is similar to maximum except removing the maximum element first. We remove the minimum element first in the minimum priority queue. In general, the queue, the elements are arranged in the order. That is a first. Suppose if you are going to insert the first element means the first element is after completion of their work of that first element, that first element is deleted first. This is the technique behind the queue. The next one is a binary heap. The binary heap, the efficient way of implementing the priority queue is the binary heap. The binary heap is merely referred as a heap. Actually, the binary heap have two properties, namely structure property, then second one is the heap order property. The structure property means a heap should be complete binary tree. If you are going to insert any element into the binary search tree, in a binary tree, we need to follow the structure priority, means it is a complete binary tree which is completely filled binary with the possible exception of the bottom level which is filled from left to right. A complete binary tree h, that is the height of the complete binary tree is maximum, that is between the 2 power h and the 2 power h plus 1 minus 1 nodes. The next one is a heap order property. In a heap, for every node x, the key in the parent of x is smaller than the key in the x. In the heap order property, we have the two types. Suppose if it is for example, the heap order property having two properties. First one is maximum heap, then second one is the minimum heap. Suppose if it is a maximum heap means then the parent is always greater than the children. Suppose if it is a minimum priority mean the parent node is always minimum than the, that is less than the children node. This is the property behind the heap order. This property allows the delete minimum operation. The delete minimum operation will be performed quickly as the minimum element can be always found at the root because the root element is always less than the other elements in that particular tree. This is a heap order property. Now we are going to explain I'm going to explain about the insert operation behind the heap operation. Insert operation means to insert an element x into the heap. first we create one hole in the next available location, because we need to keep the structure property. For the structure property, we need to fill the values from the left to right at the bottom level. So we need to create the next hole in the next available location, otherwise the tree will not be complete. So if x can be placed in the hole without violating the heap order, because the heap order property we follows the, that is, the root is always minimum than the children's. So we need to check whether any heap order property is violated, or then place the element x in there itself. Otherwise we slide the element that is in the hole's parent node into the hole, thus bubbling the hole up toward the root. This process continues until eggs can be placed in the hole. This is the technique behind the insert operation of the basic, that is the heap tree. Then next one is the delete minimum. The delete minimum operation is the deleting the minimum element from the heap. In a binary heap, always the minimum element is found in the root. So we can easily remove it. After removing, when this minimum is removed, a hole is created at the root. So we can replace this hole by any one element from the tree. That element is available in the location of this. That means since the heap becomes one smaller, makes the last element x in the heap to move somewhere in the heap. If x can be placed in the hole without violating the heap order property, place it. Otherwise, we slide the smaller of the hole's children into the hole, thus bubbling, that is pushing the hole down one level. We repeat until x can be placed in the hole. This general strategy is known as percolate down. The general strategy behind the insert operation is percolate up. Thank you.